So here we're comparing fractions with different denominators, but these are more difficult than the questions we've done so far, because 7 isn't in the 3 times table, 8 isn't in the 6 times table, and 11 isn't in the 5 times table. 11 isn't a multiple of 5. So when this happens, what you need to do is find two equivalent fractions. So 21 is in both the 3 and the 7 times table. So we can find equivalent fractions to 1/3 and to 2/7, which have a denominator of 21. 3 times 7 is 21, and 1 times 7 is 7. 7 times 3 is 21, and 2 times 3 is 6. So, because 7 over 21 is larger, we know that 1/3 is larger than 2/7. Now, 5/6 and 7/8. Again, we need to find two equivalent fractions. And we can use the common denominator of 24, because 24 is in both the 6 and the 8 times tables. It's the lowest common multiple of 6 and 8. So 6 times 4 is 24, 5 times 4 is 20, 8 times 3 is 24, and 7 times 3 is 21. So 7/8 is our larger fraction. Now for 3/5 and 7/11, we can use 55 as our common denominator, because 55 is in both the 5 and the 11 times tables. 5 times 11 is 55, 3 times 11 is 33. 11 times 5 is 55, 7 times 5 is 35, so this is our larger fraction. 7 over 11 is greater than 3 over 5. Now we're comparing improper fractions, so we need to work out which is larger, 4/3 or 7/5. Now to compare fractions, it helps if the denominators are the same, but 5 isn't in the 3 times table, and that means we'll need to change both fractions. Now 15 is in both the 3 and the 5 times tables, so we can find equivalent fractions to 4/3 and to 7/5, which have a denominator of 15. 3 times 5 is 15, 4 times 5 is 20, 5 times 3 is 15, 7 times 3 is 21. So we know that 7/5 is our larger fraction. Now we're comparing 7/5 and 3/2, but again 5 isn't in the 2 times table, which means we need to find equivalent fractions for both 7/5 and 3/2. Now 10 is in both the 5 and the 2 times tables, so we can find equivalent fractions to 7/5 and to 3/2, which have a denominator of 10. 5 times 2 is 10, 7 times 2 is 14, 2 times 5 is 10, and 3 times 5 is 15. So 3/2 is our larger fraction. We have 1/2, 5/8, 7/12, and 2/3, and we need to order these fractions from smallest to largest. Now it's easier to compare and order fractions if the denominators are the same. Now the largest denominator we have is 12, and 12 is in the 2 and 3 times table, but it's not in the 8 times table, so we can't use 12 as our common denominator. So when this happens, what you can do is count up in steps of the largest denominator. So the next multiple of 12 is 24, that's 2 times 12, and 24 is in the 2, 8, and 3 times table. So we can find equivalent fractions to 1/2, 5/8, 7/12, and 2/3, which have a denominator of 24. 2 times 12 is 24, 1 times 12 is 12, 8 times 3 is 24, 5 times 3 is 15, 12 times 2 is 24, 7 times 2 is 14, and 3 times 8 is 24, 2 times 8 is 16. So now the smallest fraction is 12 over 24, which is equivalent to 1/2. Next smallest is 14 over 24, which is equivalent to 7/12. Then we have 15 over 24, which is the same as 5/8. And then our largest fraction is 16 over 24, which is equivalent to 2/3. We need to order these fractions from smallest to largest. So we have 19/12, 9/5, 16/10, and 9/6. So we have improper fractions. Now we could change these to mixed numbers, and that might make it easier for us. But the method that we've used will still work for improper fractions. So let's try using the same method. Remember, to compare fractions, it's much easier if the denominators are the same. So we need to find a common multiple of 12, 5, 10, and 6. Now 12 is in the 6 times table, but it's not in the 5 or 10 times tables, so we need to try something else. What I do here is count up in steps of the largest denominator until I've got something that is a multiple of all of the numbers that we're comparing. So 24 doesn't work because 24 is not in the 5 times table. 36 doesn't work. 48 doesn't work. But 60 is in the 5 times table, the 10 times table, and the 6 times table. So we can find equivalent fractions with a denominator of 60. 12 times 5 is 60, and 19 times 5 is 95. You might need to use column method there to work that out. Now 5 times 12 is 60, and 9 times 12 is 108. 10 times 6 is 60, and 16 times 6 is 96. Again, you might need the column method. 6 times 10 is 60, and 9 times 10 is 90. So now we've got our common denominator, so we can compare these fractions. The smallest is 90 over 60, so originally that was 9 over 6. Then we have 95 over 60, so that's 19 over 12. Then 96 over 60, which was 16/10, and our largest fraction is 108 over 60, which is 9/5. 1/2 plus 1/9. So to add fractions, we know that we need the denominators to be the same. But 9 isn't in the 2 times table. 9 isn't a multiple of 2. So we'll need to find 2 equivalent fractions for both 1/2 and for 1/9. Now 18 is in both the 2 and the 9 times table. So we can find equivalent fractions to 1/2 and to 1/9, which have a denominator of 18. 2 times 9 is 18, and 1 times 9 is 9. 9 times 2 is 18, and 1 times 2 is 2. So now we can rewrite our question. Instead of 1/2, we can write 9/18, and instead of adding 1/9, we can add 2/18. So now we have a common denominator. So the denominator stays the same in our answer, and 9 plus 2 is 11. So our answer is 11/18. Now 1/5 plus 4/7. Again, we need the denominators to be the same, but 7 isn't a multiple of 5, so we need to change both fractions. 35 is in both the 5 and the 7 times table, so we can find equivalent fractions with 35 as our denominator. Now 5 times 7 is 35, 1 times 7 is 7, so 1/5 is equivalent to 7 over 35. Now 7 times 5 is 35, and 4 times 5 is 20. So we can rewrite our question. Instead of 1/5, we can write 7 over 35, and instead of adding 4/7, we can add 20 over 35. So now we have a common denominator, so the denominator stays the same in our answer, and 7 plus 20 is 27. So our answer is 27 over 35. So here we're subtracting fractions. But to subtract fractions, the denominators need to be the same. Now the lowest common multiple of 6 and 4 is 12, so we can find equivalent fractions to 5/6 and 1/4, which have a denominator of 12. 6 times 2 is 12, and 5 times 2 is 10. 4 times 3 is 12, 1 times 3 is 3. So instead of 5/6, we can write 10 over 12, and instead of subtracting 1/4, we can subtract 3 over 12. Now we have a common denominator, so the denominator stays the same in our answer, and 10 minus 3 is 7, so our answer is 7/12. Now 3/5 minus 2/7. Well, 35 is in both the 5 and the 7 times table, so we can find equivalent fractions to 3/5 and 2/7, which have a denominator of 35. 5 times 7 is 35, 3 times 7 is 21, 7 times 5 is 35, and 2 times 5 is 10. So instead of 3/5, we can write 21 over 35, and instead of 2/7, we can subtract 10 over 35. So the denominator stays the same in our answer, and 21 minus 10 is 11. So our answer is 11 over 35. Now we have some missing number or missing fraction addition and subtraction problems. Now this first problem is a missing number addition, and whenever we have a missing number addition, we always use subtraction to find the missing number. So we need to work out 5/6 minus 2/5 to find our missing fraction. But to subtract fractions, we need the denominators to be the same. 30 is in both the 6 and the 5 times tables, so we can find equivalent fractions to 5/6 and 2/5 with a denominator of 30. 6 times 5 is 30, 5 times 5 is 25, 5 times 6 is 30, and 2 times 6 is 12. So instead of 5/6, we can write 25 over 30, and instead of subtracting 2/5, we can subtract 12 over 30. Now when we're subtracting, the denominator stays the same. 25 minus 12 is 13, so our missing fraction is 13 over 30. Now we have a missing number subtraction problem, but it's the second number in the subtraction that's missing, so we still use subtraction to find our answer. We need to work out 1/3 minus 1/8, and that will tell us our missing fraction. But to subtract fractions, we need the denominators to be the same. 24 is in the 3 and the 8 times tables, so let's find our equivalent fractions. 3 times 8 is 24, 1 times 8 is 8. 8 times 3 is 24, 1 times 3 is 3. So instead of 1/3, we can write 8 over 24, and instead of subtracting 1/8, we can subtract 3 over 24. We keep the denominator the same, and 8 minus 3 is 5, so our missing fraction is 5 over 24. Now, something minus 2/7 equals 1/8. So here, because it's the first number of our subtraction that's missing, we use the inverse operation, we use addition to find our answer. Because remember, subtraction problems can be read backwards as addition problems. So if we work out 1/8 plus 2/7, we'll find our missing number. Now the denominators need to be the same, and 56 is in both the 8 and the 7 times tables. So let's find our equivalent fractions. 8 times 7 is 56, 1 times 7 is 7, 7 times 8 is 56, 2 times 8 is 16. So instead of 1/8, we can write 7 over 56, and instead of adding 2/7, we can add 16 over 56. The denominator stays the same in our answer, and 7 plus 16 is 23. So our answer is 23 over 56. So for these questions, we're adding fractions, and we have two answer boxes. And that's because we're going to express our answer as both an improper fraction and a mixed number. Now we know that to add fractions, we need the denominators to be the same. 15 is in both the 5 and the 3 times table, so we can find equivalent fractions to 4/5 and 2/3, which have a denominator of 15. 5 times 3 is 15, 4 times 3 is 12, 3 times 5 is 15, 2 times 5 is 10. So we can rewrite our question. Instead of 4/5, we can write 12 over 15, and instead of 2/3, we can add 10 over 15. So now we have a common denominator, so we keep the denominator the same in our answer, and 12 plus 10 is 22. So as an improper fraction, our answer is 22 over 15. But as a mixed number, we write that as 1 and 7 over 15, because 22 divided by 15 is 1 remainder 7, and the denominator stays the same. Now 7/8 plus 1/6. Now 24 is in both the 8 and the 6 times table, so we can find equivalent fractions with a denominator of 24. 8 times 3 is 24, 7 times 3 is 21, 6 times 4 is 24, and 1 times 4 is 4. So instead of 7/8, we can write 21 over 24, and instead of adding 1/6, we can add 4 over 24. The denominator stays the same in our answer, and 21 plus 4 is 25. So as an improper fraction, our answer is 25 over 24, and as a mixed number, we write that as 1 and 1 over 24. Now we have 1 and 1/3 minus 1/2. We know that to subtract fractions, we need the denominators to be the same. Now 6 is in both the 3 and the 2 times tables, so we can find equivalent fractions to 1/3 and 1/2 with a denominator of 6. 3 times 2 is 6, 1 times 2 is 2, 2 times 3 is 6, 1 times 3 is 3. So we can rewrite our question. Instead of 1 and 1/3, we can have 1 and 2/6, and instead of subtracting 1/2, we can subtract 3/6. But we have a problem here. If we look at our fractions, we can't take 3/6 away from 2/6, so we need to change 1 and 2/6 to an improper fraction. That's 8/6, because 1 times 6 is 6 plus 2 is 8, and now we can subtract 3/6. Our denominator stays the same, 8 minus 3 is 5, so our answer is 5/6. Now 1 and 1/4 minus 3/5. Now 20 is in both the 4 and the 5 times tables, so we can find equivalent fractions to 1/4 and 3/5 with a denominator of 20. 4 times 5 is 20, 1 times 5 is 5, 5 times 4 is 20, 3 times 4 is 12. So we have 1 and 5/20 minus 12/20. But again, if we start with 5/20, we can't subtract 12/20, so we need to change this to an improper fraction. 1 and 5/20 is 25/20 as an improper fraction, because 1 times 20 is 20, plus 5 is 5, and the denominator stays the same. And now we can subtract 12/20. Our denominator stays the same. 25 minus 12 is 13, so our answer is 13/20. So here we have some missing number or missing fraction subtraction problems. Now for this first problem, it's the second number in our subtraction that's missing. And in missing number problems, if the second number is missing, then we still subtract to find our missing number. So we need to work out 1 1/8 minus 4/5 to find our missing number. Now as an improper fraction, 1 1/8 is 9/8 and we're subtracting 4/5. But to subtract fractions, we need our denominators to be the same. Now 40 is in both the 8 and the 5 times table, so we can find equivalent fractions to 9/8 and 4/5, which have a denominator of 40. 8 times 5 is 40, 9 times 5 is 45, 5 times 8 is 40, 4 times 8 is 32. So instead of 1 1/8 or 9/8, we can have 45 over 40, and instead of subtracting 4/5, we can subtract 32 over 40. So now we have a common denominator, so that stays the same in our answer, and 45 minus 32 is 13. So our missing fraction is 13 over 40. Now for this problem, it's the first number in our subtraction that's missing. And we know that subtraction problems can be read backwards as addition problems. So to find this missing number, we're going to use the inverse operation. We're going to add 5/6 and 5/8, and that will give us our missing fraction. But to add fractions, we need the denominators to be the same. So the lowest common multiple of 6 and 8 is 24. So we can find equivalent fractions to 5/6 and 5/8, which have a denominator of 24. 6 times 4 is 24, 5 times 4 is 20, 8 times 3 is 24, 5 times 3 is 15. So instead of 5/6, we can have 20 over 24, and instead of adding 5/8, we can add 15 over 24. Now we keep the denominator the same in our answer. 20 plus 15 is 35, so our missing fraction is 35 over 24, which, if we want to write as a mixed number, is 1 and 11 over 24, because 35 divided by 24 is 1, remainder 11, and the denominator stays the same. So now we have a missing number or missing fraction addition problem. And with addition, if there's a number missing, we always use subtraction to find our missing number. So we need to take 1 1/5 and subtract 1/2. Now as an improper fraction, 1 1/5 is 6/5. We're subtracting 1/2, but to subtract fractions, we need our denominators to be the same. Now 10 is in both the 5 and the 2 times table, so we can find equivalent fractions to 6/5 and 1/2, which have a denominator of 10. 5 times 2 is 10, 6 times 2 is 12, 2 times 5 is 10, 1 times 5 is 5. So instead of 6/5, we can have 12/10, and instead of subtracting 1/2, we can subtract 5/10. The denominator stays the same, and 12 minus 5 is 7, so our missing fraction is 7/10. Now we're adding a fraction to a mixed number. But to add fractions, we need denominators to be the same. Now 30 is in both the 5 and the 6 times table, so we can find equivalent fractions to 3/5 and 1/6, which have denominators of 30. 5 times 6 is 30, 3 times 6 is 18, 6 times 5 is 30, 1 times 5 is 5. So instead of 1 3/5, we can have 1 and 18 over 30, and instead of adding 1/6, we can add 5 over 30. So the 1 whole stays the same, we keep the denominator of our fraction the same, and 18 plus 5 is 23. So we have 1 and 23 over 30, and that's our answer. Now 2 and 1/3 plus 3/5. We need the denominators to be the same, and 15 is in both the 3 and the 5 times table. So we can find equivalent fractions to 1/3 and 3/5, which have a denominator of 15. 3 times 5 is 15, 1 times 5 is 5, 5 times 3 is 15, 3 times 3 is 9. So instead of 2 and 1/3, we can write 2 and 5 over 15, and instead of adding 3/5, we can add 9 over 15. The only whole number we have is 2, the denominator stays the same, and 5 plus 9 is 14. So we have 2 and 14 over 15 as our answer. 1 and 3/4 plus 4/5. So we need to change our fractions so that they have a common denominator. Now 20 is in both the 4 and the 5 times table, so we can find equivalent fractions to 3/4 and 4/5, which have a denominator of 20. 4 times 5 is 20, 3 times 5 is 15, 5 times 4 is 20, 4 times 4 is 16. So instead of 1 and 3/4, we can write 1 and 15/20, and instead of adding 4/5, we can add 16/20. So now the only whole number we're adding is 1, and now 15/20 plus 16/20 is 31/20, because remember, when we're adding fractions, the denominator stays the same. But we have a problem here. We can't write 1 and 31/20 as our answer, because we can't have an improper fraction in a mixed number. So we need to change 31/20 back into a mixed number. We still have one whole, but now 31/20 is the same as 1 and 11/20, because 31 divided by 20 is 1 remainder 11. So now 1 plus 1 is 2, the 11/20 stays the same, so our answer is 2 and 11/20. Now 2 and a half plus 6/7. So 14 is in both the 2 and the 7 times table, so we can find equivalent fractions to 1/2 and 6/7, which have a denominator of 14. 2 times 7 is 14, 1 times 7 is 7, 7 times 2 is 14, 6 times 2 is 12. So we can rewrite our question. Instead of 2 and a half, we have 2 and 7 over 14, and instead of 6/7, we're adding 12 over 14. So our only whole number that we're adding is just this 2, and then 7/14 plus 12/14 is 19/14, because the denominator stays the same, and 7 plus 12 is 19. But we have a problem. Again, we can't write 2 and 19/14 as our answer, because we can't have an improper fraction in a mixed number. So instead of 2 plus 19/14, we can have 2 plus 1 and 5/14, because 19 divided by 14 is 1 remainder 5. So now 2 plus 1 is 3, the 5/14 stays the same, so our answer is 3 and 5/14. So here we're adding a fraction to a mixed number, but this time we're going to answer the question by changing our mixed number to an improper fraction. So as an improper fraction, 1 and 3/4 is 7/4, because 1 times 4 is 4, plus 3 is 7, the denominator stays the same. And we're still adding 4/5. But we know that to add fractions, we need the denominators to be the same. 20 is in both the 4 and the 5 times table, so we can find equivalent fractions to 7/4 and 4/5, which have a denominator of 20. 4 times 5 is 20, 7 times 5 is 35, 5 times 4 is 20, 4 times 4 is 16. So we can rewrite our question again. Instead of 1 and 3/4, or 7/4, we can write 35 over 20. and instead of adding 4/5, we can add 16 over 20. So now we have our common denominator, so we keep the denominator the same in our answer, and 35 plus 16 is 51. Now, if we want to change our answer back into a mixed number, we can divide, and 51 divided by 20 is 2 remainder 11, because 2 times 20 is 40, then we need 11 more to get to 51. Our denominator stays the same, so our denominator is still 20, which means our answer is 2 and 11 over 20. Now, 2½ plus 6/7. So we can change our mixed number to an improper fraction. That's 5 over 2, because 2 times 2 is 4, plus 1 is 5, the denominator stays the same. We're adding 6/7, but to add fractions we need a common denominator. 14 is in both the 2 and the 7 times table, so we can find equivalent fractions with a denominator of 14. 2 times 7 is 14, 5 times 7 is 35, 7 times 2 is 14, 6 times 2 is 12. So now we can rewrite our question. Instead of 2½ or 5 over 2, we can write 35 over 14. And instead of adding 6/7, we can add 12 over 14. So now we're adding fractions with a common denominator, so we can keep the denominator the same in our answer. 35 plus 12 is 47, so our answer is 47 over 14. Now, if we want to change that back into a mixed number, it's quite tricky, but 47 divided by 14 is 3 remainder 5. That's because 3 times 14 is 42, but then from 42 we need 5 more to get to 47. Our denominator stays the same, so our denominator is 14, which means our answer is 3 and 5 over 14. Now we're adding mixed numbers, and to do this we need the fraction parts of our mixed numbers to have a common denominator. Now 42 is in both the 6 and the 7 times table, so we can find equivalent fractions to 5/6 and 1/7, which have a denominator of 42. 6 times 7 is 42, 5 times 7 is 35, 7 times 6 is 42, 1 times 6 is 6. So now we can rewrite our question. Instead of 2 and 5/6, we can write 2 and 35 over 42, and instead of 1 and 1/7, we can add 1 and 6 over 42. So we add our fractions first. The denominator stays the same when we're adding fractions. 35 plus 6 is 41, and now we add our whole numbers. 2 plus 1 is 3, so our answer is 3 and 41 over 42. Now 2 and 2/9 plus 2½ so we need our fractions to have a common denominator. 18 is in both the 9 and the 2 times table, so we can find equivalent fractions to 2/9 and 1/2, which have a denominator of 18. 9 times 2 is 18, 2 times 2 is 4, 2 times 9 is 18, 1 times 9 is 9. So instead of 2 and 2/9, we can have 2 and 4 over 18, and instead of adding 2½ we can add 2 and 9 over 18. So we add the fractions first. When we're adding fractions, we keep the denominator the same, so that's 18. We add the numerators of the fractions, so 4 plus 9 is 13. Then we add the whole numbers, and 2 plus 2 is 4. So our answer is 4 and 13 over 18. We have 2½ plus 2 3/5. So we're adding mixed numbers, and the first thing we do is get the denominators of our fractions the same. So 10 is in the 2 and the 5 times table, so we can find equivalent fractions to 1/2 and 3/5, which have a denominator of 10. 2 times 5 is 10, 1 times 5 is 5, 5 times 2 is 10, 3 times 2 is 6. So we can rewrite our question. Instead of 2.5, we can write 2 and 5/10, and instead of adding 2 and 3/5, we can add 2 and 6/10. So 2 plus 2 is 4, and 5/10 plus 6/10 is 11/10, because remember, we keep the denominator the same. But we have a problem here. We can't write 4 and 11/10 as our answer, because we can't have an improper fraction in a mixed number. So we need to change 11/10 back into a mixed number. So instead of 4 plus 11/10, we have 4 plus 1 and 1/10, because 11 divided by 10 is 1 remainder 1, and the denominator stays the same. So now 4 plus 1 is 5, we keep the 1/10, so our answer is 5 and 1/10. Now 2 and 4/5 plus 1 and 3/4. So we need our fractions to have a common denominator, and 20 is in both the 5 and the 4 times table. So we find equivalent fractions with a denominator of 20. 5 times 4 is 20, 4 times 4 is 16, 4 times 5 is 20, 3 times 5 is 15. So instead of 2 and 4/5, we can write 2 and 16/20, and instead of adding 1 and 3/4, we can add 1 and 15/20. Now 2 plus 1 is 3, and 16 plus 15 is 31. We keep the denominator the same, so we have 3 plus 31/20, but we can't write 3 and 31/20 as our answer, because we can't have an improper fraction in a mixed number. So we need to change 31/20 to a mixed number. Instead of adding 3 plus 31/20, we can have 3 plus 1 and 11/20, because 31 divided by 20 is 1 remainder 11. So 3 plus 1 is 4, we still have our 11/20, so our answer is 4 and 11/20. So here we're adding mixed numbers, but this time we're going to do that by changing both mixed numbers into improper fractions. So as an improper fraction, 2.5 is 5 over 2. That's because 2 times 2 is 4 plus 1 is 5, and the denominator stays the same. And we're adding 2 and 3/5, which as an improper fraction is 13 over 5, because 2 times 5 is 10 plus 3 is 13. But we know that when we're adding fractions, we need the denominators to be the same. So 10 is in both the 2 and the 5 times table, so we can find equivalent fractions with a denominator of 10. 2 times 5 is 10, 5 times 5 is 25, 5 times 2 is 10, 13 times 2 is 26. So we can rewrite our question again. Instead of 2.5 or 5 over 2, we can write 25 over 10, and instead of adding 2 and 3/5 or 13 over 5, we can add 26 over 10. So now we have a common denominator, so the denominator stays the same in our answer, and 25 plus 26 is 51. So our answer is 51 over 10. But if we want to turn that back into a mixed number, we can divide. 51 divided by 10 is 5 remainder 1. The denominator stays 10, so our answer is 5 and 1/10. Now 2 and 4/5 plus 1 and 3/4. Again, we can change both mixed numbers into improper fractions. 2 times 5 is 10 plus 4 is 14, so that's 14/5, and 1 times 4 is 4 plus 3 is 7, so that's 7/4. Again, when we're adding fractions, we need the denominators to be the same, and 20 is in both the 5 and the 4 times table, so we can find equivalent fractions with a denominator of 20. 5 times 4 is 20, And for 14 times 4, you might need to use short multiplication here, but that's 56. Then 4 times 5 is 20, and 7 times 5 is 35. So we can rewrite our question again. Instead of 2 and 4 fifths, or 14 fifths, we can write 56 over 20, and instead of adding 1 and 3 quarters, or 7 quarters, we can add 35 over 20. So we're adding fractions, so the denominator stays the same, and 56 plus 35, you might need to use column method for this, but that gives us 91. So our answer is 91 over 20. Now, if we want to change that back into a mixed number, we need to divide. So 91 divided by 20 is 4 remainder 11. That's because 4 times 20 is 80, then we need 11 more to get to 91. Our denominator stays over 20, so our answer is 4 and 11 twentieths. Now we're subtracting a fraction from a mixed number, and when we're subtracting, we need the denominators to be the same. So 28 is in both the 7 and the 4 times table, so we can find equivalent fractions to 6/7 and 3 quarters, which have a denominator of 28. 7 times 4 is 28, 6 times 4 is 24, 4 times 7 is 28, 3 times 7 is 21. So now we can rewrite our question. Instead of 1 and 6/7, we can write 1 and 24 over 28, and instead of subtracting 3 quarters, we can subtract 21 over 28. Now, if we subtract our fractions first, 24 28ths minus 21 28ths is 3 28ths, because remember, when we subtract fractions, the denominator stays the same, and then we just have 1 minus nothing, so we still have 1 in our answer. So our answer is 1 and 3 28ths. Now, 2 and 5 ninths minus 1/2. So we need to get our denominators the same. 18 is in both the 9 and the 2 times tables, so we can use 18 as our common denominator. 9 times 2 is 18, 5 times 2 is 10, 2 times 9 is 18, and 1 times 9 is 9. So instead of 2 and 5 ninths, we can rewrite our question as 2 and 10 18ths, and instead of subtracting 1/2, we can subtract 9 18ths. Now we always subtract the fractions first, so 10 18ths minus 9 18ths is 1 18th, and 2 minus nothing is 2, so our answer is 2 and 1 18th. 2 and 1/6 minus 1 quarter. So when we're subtracting fractions, we need our denominators to be the same. 12 is in both the 6 and the 4 times table, so we can use 12 as our common denominator. 6 times 2 is 12, 1 times 2 is 2. Now 4 times 3 is 12, 1 times 3 is 3. So we can rewrite our question. Instead of 2 and 1/6, we can have 2 and 2/12, and instead of subtracting 1 quarter, we can subtract 3/12. But now we have a problem. If we look at our fractions, we're subtracting 3/12 from 2/12, and when this happens, we need to exchange with our whole number. So what we can do is take 1 away from our whole number, so 1 less than 2 is 1, and that means that we can add the denominator to the numerator. 12 plus 2 is 14, so instead of 2 and 2/12, we can have 1 and 14/12. We're subtracting 3/12, so now if we subtract the fractions, 14/12 minus 3/12 is 11/12, and we have 1 minus no whole number here, so we keep the 1, and our answer is 1 and 11/12. Now 2 and 1/2 minus 2/3. So we need our fractions to have common denominators, and 6 is in both the 2 and the 3 times table, so we can use 6 as our common denominator. 2 times 3 is 6, 1 times 3 is 3, 3 times 2 is 6, and 2 times 2 is 4. So we can rewrite our question. Instead of 2½ that's 2 3/6, and instead of subtracting 2/3, we can subtract 4/6. But again, we have a problem because the fraction we're subtracting is larger than the fraction in our mixed number. So here we're going to need to exchange 1 whole for 6 more sixths. So instead of 2, we have 1, and instead of 3/6, because we can add the denominator to the numerator, 6 plus 3 is 9, so we have 1 9/6. We're subtracting 4/6, so if we subtract the fractions, 9/6 minus 4/6 is 5/6, and then 1 minus nothing is 1, so our answer is 1 5/6. Now we're still subtracting a fraction from a mixed number, but this time we're going to solve this by changing the mixed number into an improper fraction. So 2 times 6 is 12, plus 1 is 13, so 2 1/6 we can write as 13 over 6, and we're subtracting 1/4. But to subtract fractions, we need the denominators to be the same. So 12 is in both the 6 times table and the 4 times table, so we can find equivalent fractions with a denominator of 12. 6 times 2 is 12, 13 times 2 is 26, 4 times 3 is 12, and 1 times 3 is 3. So instead of 13 over 6, we can write 26 over 12, and instead of subtracting 1 over 4, we can subtract 3 over 12. So when subtracting fractions, we keep the denominators the same, and 26 minus 3 is 23. So our answer is 23 over 12. But if we want to change that back into a mixed number, we can use division. 23 divided by 12 is 1 remainder 11. We can keep our denominator over 12, so our answer is 1 11/12. Now 2½ minus 2/3. So as an improper fraction, 2½ is 5 over 2, because 2 times 2 is 4, plus 1 is 5. And we're subtracting 2/3, but we need our denominators to be the same. 6 is in both the 2 and the 3 times table. 2 times 3 is 6, 5 times 3 is 15, 3 times 2 is 6, 2 times 2 is 4. So instead of 5 halves, we can write 15/6, and instead of 2/3, we can subtract 4/6. So now we keep the denominator the same in our answer. 15 minus 4 is 11, so our answer is 11/6. And if we want to change that back into a mixed number, we can use division. 11 divided by 6 is 1 remainder 5. We keep the denominator over 6, so our answer is 1 5/6. We have 2 3/5 minus 1 1/3. So when we're subtracting fractions, we need the denominators to be the same. 15 is in both the 5 and the 3 times table, so we can find equivalent fractions with a denominator of 15. 5 times 3 is 15, 3 times 3 is 9, 3 times 5 is 15, 1 times 5 is 5. So now we can rewrite our question. Instead of 2 3/5, we can write 2 9/15, and instead of subtracting 1 1/3, we can subtract 1 5/15. Now we've got the denominators the same, so we start by subtracting the fractions. And this is really important because if this number was larger than this numerator, we'd need to use a different method. So to start, we have 9/15 minus 5/15, which is 4/15, and then we can subtract the whole numbers, so 2 minus 1 is 1. Now, 2 and 7/9 minus 1 and 3/8. We need our denominators to be the same, and 72 is in both the 9 and the 8 times table, so we can find equivalent fractions with a denominator of 72. 9 times 8 is 72, 7 times 8 is 56, then 8 times 9 is 72, 3 times 9 is 27. So we can rewrite our question. Instead of 2 and 7/9, we can have 2 and 56 over 72, and instead of subtracting 1 and 3/8, we can subtract 1 and 27 over 72. So we start by subtracting the fraction part of the question. 56 minus 27, you might need to use column method for this, but that's 29, and we keep the denominator the same, and then 2 minus 1 is 1, so our answer is 1 and 29 over 72. We have 3 and a quarter minus 1 and a third. So when we're subtracting fractions, we need the denominators to be the same. 12 is in both the 4 and the 3 times table, so let's find equivalent fractions with a denominator of 12. 4 times 3 is 12, 1 times 3 is 3, 3 times 4 is 12, 1 times 4 is 4. So now we can rewrite our question. Instead of 3 and a quarter, we can write 3 and 3/12, and instead of subtracting 1 and 1/3, we can subtract 1 and 4/12. But we have a problem here. If we look at the fractions, we've got 3/12 minus 4/12, and when we have that, we need to exchange with our whole number. So what we do is take 1 from our whole number, so 1 less than 3 is 2, and that means we can add the denominator to the numerator, so 12 plus 3 is 15, so we can write 2 and 15/12 instead of 3 and 3/12, and we're still subtracting 1 and 4/12. So now we can subtract the fractions. 15/12 minus 4/12 is 11/12, and we need to remember to subtract the whole numbers as well. 2 minus 1 is 1, so our answer is 1 and 11/12. Now 4 and 2/5 minus 1 and a half. So we need our fractions to have the same denominator. 10 is in both the 5 and the 2 times table, so we can use 10 as our common denominator. 5 times 2 is 10, 2 times 2 is 4, 2 times 5 is 10, 1 times 5 is 5. So we can rewrite our question. Instead of 4 and 2/5, we can write 4 and 4/10, and instead of subtracting 1 and a half, we can subtract 1 and 5/10. But again, we've got the same problem. If we look at our fractions, we can't take 5/10 away from 4/10, so we need to use the exchanging trick again. Remember, we take 1 away from our whole number, so 1 less than 4 is 3, and then we can add the denominator to the numerator. So 10 plus 4 is 14, so we can write 3 and 14/10 instead of 4 and 4/10. We're still subtracting 1 and 5/10, so we can start by subtracting our fractions. 14/10 minus 5/10 is 9/10, and then we subtract our whole numbers. 3 minus 1 is 2, so our answer is 2 and 9/10. So here, again, we're subtracting mixed numbers, but the method we're going to use this time is to turn these mixed numbers into improper fractions. So as an improper fraction, 3 and 1/4 is 13/4, because 3 times 4 is 12, plus 1 is 13, the denominator stays the same, and we're subtracting 1 and 1/3, which, as an improper fraction, is 4/3, because 1 times 3 is 3, plus 1 is 4. So when we're subtracting or adding fractions, we need the denominators to be the same. Now 12 is in both the 4 and the 3 times table, So we need to find equivalent fractions to 13 quarters and 4 thirds, which have a denominator of 12. Now we use multiplication, so 4 times 3 is 12, 3 times 3 is 39, 3 times 4 is 12, and 4 times 4 is 16. So now we can rewrite our question again. So remember, first of all, we rewrote the question with the mixed numbers as improper fractions, but now we have our equivalent improper fractions, we can rewrite the question again. So instead of 13 quarters, we can write 39 twelfths, and instead of subtracting 4 thirds, we can subtract 16 twelfths. So now that we've got our denominators the same, we can keep the denominator the same in our answer, and we have 39 minus 16, which is 23. So we could answer 23 twelfths, but if we want to turn that back into a mixed number, we can divide. 23 divided by 12 is 1, remainder 11, so the remainder is our numerator, and we keep the denominator the same as it is here. So our answer is 1 and 11 twelfths. Now let's follow the same method with 4 and 2 fifths minus 1 and 1 half. The first step is to rewrite the question with improper fractions. Now 4 times 5 is 20, plus 2 is 22, so 22 fifths is the same as 4 and 2 fifths, and we're subtracting 1 and a half as an improper fraction, that's 3 over 2. Now we're subtracting, but when we subtract fractions, we need the denominators to be the same. Our denominators are 5 and 2, and 10 is in both the 5 and the 2 times table. So we can find equivalent fractions with a denominator of 10. 5 times 2 is 10, 22 times 2 is 44. 2 times 5 is 10, 3 times 5 is 15. So now we can rewrite our question again. Instead of 22 fifths, we can write 44 tenths. And instead of subtracting 3 halves, we can subtract 15 tenths. So now we've got our denominators the same, so we keep the denominator the same in our answer. 44 minus 15 is 29, so our answer is 29 tenths. If we want to turn that back into a mixed number, we can divide. 29 divided by 10 is 2, remainder 9, and the denominator stays what it is here, so that's over 10, so our answer is 2 and 9 tenths. Which fraction lies halfway between 4 sevenths and 2 thirds? So we need to find the midpoint. Now one method would be to use the same method that we use when we're finding the number halfway between two whole numbers. We could add these together and then divide by 2. But another method is just to use equivalent fractions to help us. So our denominators are 7 and 3, and 21 is in both the 7 and the 3 times table. So we can find equivalent fractions to 4 sevenths and 2 thirds, which have a denominator of 21. Now 7 times 3 is 21, 4 times 3 is 12, 3 times 7 is 21, and 2 times 7 is 14. So now the question's a lot easier. We can easily see what's halfway between 12 over 21 and 14 over 21. Well, that's going to be 13 over 21. Now, which fraction lies halfway between 2 sevenths and 1 third? So we could add them together and then divide by 2, or we can use equivalent fractions. Again, 7 and 3 are our denominators, so we can find equivalent fractions to 2 sevenths and 1 third with denominators of 21, because 21 is in both the 7 and the 3 times table. 7 times 3 is 21, 2 times 3 is 6, 3 times 7 is 21, 1 times 7 is 7. So we need to find what's halfway between 6 over 21 and 7 over 21. Now this is tricky. You know that halfway between 6 and 7 you have 6 and a half, but it's not but we can't write 6½ over 21. It's better, if we get this situation, to just find more equivalent fractions. So if we double 21, we get 42. So 21 times 2 is 42. 6 times 2 is 12. Again, 21 times 2 is 42. 7 times 2 is 14. So now we can see the midpoint. We've got 12 over 42 and 14 over 42. So the midpoint is 13 over 42.